Okay, grade 12, I'm not going to lie, I'm getting very frustrated with the technology I have to use. Not sure what's going on, but let's try the second half of this video and hopefully the volume will work. I am now sitting in my basement screaming at my TV and computer, so hopefully you will be able to hear what I have to say. I was talking about ethane, ethene, and ethine and talking about how the intermolecular forces between their molecules do not vary greatly, and therefore they have similar boiling points. So as I was trying to illustrate, and I don't know what I am doing to stop my recording voice, so I don't want to touch any of these buttons up at the top again, but what I was trying to show you is that between two molecules of ethane, the intermolecular forces are roughly the same strength as between two molecules of ethene, two molecules of ethine, and so on. That's why they have similar boiling points. It's going to take roughly the same amount of energy to separate two molecules of ethane as it will to separate ethene, ethine, and etc. Okay, so that's what that data table was to show you. Moving along, these are two molecules of multiple bonds. So this first one I had represented had a triple bond. This yellow was just supposed to represent the longest chain that contains that multiple bond. There are 5 carbons. That's where I got this pent because of the 5 carbons. Okay, where is that triple bond? Remember, the triple bond takes precedence. And that means that I'm going to start numbering closest to the triple bond. So I'm going to start numbering over here. 1, 2 is where that triple bond starts. If I start numbering from the right, 1, 2, 3 carbons is where the triple bond starts. So in this case, I have to number from the left, 1, 2 for that multiple bond, and then off the fourth is a methyl group. And that's what this is right here, the methyl group. Okay? Down here, this is a multiple bond, but there's 2 of them. So instead of saying 1, 2, 3, 4 butene, because of the 4 carbons, instead of saying butene, we actually put diene because there's 2 double bonds. So I'm putting di in front of that ene. I leave the A from butane just because it's going to be a lot easier to say. If I take that A out, it's butadiene. Okay, so we're going to say butadiene. And again, you want to make it so that the multiple bond has the lowest numbers possible, and you have to continually name from left to right or right to left. So I can't say, oh, this is off my first and this is off my first. Can't do that. So let's start here. First carbon has a multiple bond and also the third carbon. So that's where I'm coming up with 1,3-butadiene. You're going to stop the video now and you're going to try these questions, and then you'll come back to the video, skip ahead a few pages, and there are the answers, okay? Then you're also going to try these 4 questions and skip to the next page and see your answers, because organic chemistry is practice, practice, practice. Now, I want to talk about isomers. Isomers are chemicals that have the same molecular formula, but they have a different rearrangement. You can have structural isomers and you can have what are called stereoisomers, okay? So structural isomers are what we're going to talk about today. And then, as I said, you can also have stereoisomers, and we'll talk about those on Wednesday. So stereoisomers, read section 22.3 from your textbook so that you will be familiar with those when I talk about them on Wednesday. Okay, so today, structural isomers. Structural isomers, as I said, have the same chemical formula, molecular formula, but they're arranged differently. So if you look at these examples taken from your textbook, you'll see butane has 4 carbons, 10 H's. And then you'll see 2-methylpropane has 4 carbons and 10 H's. Now, I'm going to argue and say that you don't even actually need that 2 at the beginning, because if you put that methyl group in any other spot, it would no longer be a propane, okay? It would be butane. So I'm going to argue and say you don't need that 2 there. Okay, if you move that methyl to the first, then you would have butane. To the end over here, and you'd have butane. I don't see the need for that 2. You will find it in resources both ways. I prefer to leave it out if we don't need it. Okay, so structural isomers, they're going to have the same molecular formula, but the atoms are going to be arranged differently. So here's another way to look at the example. You see 4 carbons and 10 H's. 4 carbons and 10 H's. All right, but they're arranged differently. Now, I thought what we would do is work through an example of hexane and its isomers. If you look at Dr. Nate here at this video, he explains it, he goes through it, but I thought I would use my newly found skills in writing on this non-smart board and show you how to do it. So again, hexane, I will tell you, has 5 isomers, first of which is hexane itself. So 1, 2, 3, 4, 5, 6. That is indeed hexane. It has 6 carbons and 14 H's. Now, what if we were indeed instead to do 1, 2, 3, 4, 5, but instead of having that 6 come off the end, let's have it, well, if we put it off the end here, I'm hoping you'd notice it would still be hexane. Okay, so let's put it off the second one instead. So now if you note, I have 1, 2, 3, 4, 5, 6 carbons still. And if you count all of the H's that would make those carbons happy, you'll find that it's still going to be C6H14. But when we go to name it, the longest chain now is actually a pentane group. That's the longest chain. And we have a methyl branch off of it. So this is actually 2-methyl pentane. Now what if we did the same thing again? 1, 2, 3, 4, 5. Okay, that's very messy. You can't have that. 1, 2, 3, 4, 5. But instead, we move that branch over off of the third. Okay, we would still have the chemical formula C6H14, but instead we would have 3-methyl pentane because now that branch is off the third. Okay, what if we did the same thing again? 1, 2, 3, 4, 5, but instead put the methyl branch off of this one. I'm hoping that you'll notice when you go to name that, it would actually be the same as this, 2-methyl pentane. Because remember, we want to give it so that the branch has the lowest number possible, so it would be the same. So when you're doing isomers, please name them as you go, because once you get to a duplicate name, you know you've exhausted the isomers for that chain. All right. Professor Nate here doesn't name until the end. I disagree with that. I would name as you went. So we've gone from a 6-length carbon chain to 5. So let's try a 4. So 1, 2, 3, 4. That means we still have 2 carbons left to place. I can't put them on the ends. That will just lengthen the chain. So let's put one off here and let's put one off here. Okay, that still follows all of our rules. So we'll have butane as our last name, but as our branches, we're going to have a methyl off the second, a methyl off the third, and so therefore it's what we call dimethyl butane. Okay, so that is indeed another isomer of hexane. Now I told you there were 5, so there must be one more. So let's try that butane again. 1, 2, 3, 4. But instead of putting the methyl groups separating them, let's put them both on the same. Okay, that still gives carbon a maximum of 4 bonds, which is okay. And if I were to use a different color, you can see how there's 1, 2, 3, 4. So there's my longest chain. So that's still butane. But when I name my branches, they're going to be 2, 2. Oops. Awkward. Dimethyl butane. Okay. Now, so far, everything I have is a different name, so I know those are all true isomers. If I wanted to break my branches down, there's no other way to move those 2 methyl groups without lengthening the chain. So if I went from hexane to pentane to butane, and then let's say to propane, how could I add those extra carbons? There's 3 carbons in a row for propane. I can add a 4th and a 5th, but when I go to add that 6th, there's no place for it to go. If I put it on the end here, I'm lengthening the chain. If I put it here, I'm lengthening the chain. And if I put it here, now I have carbon with 5 around it, and that's not possible. So I have indeed found all of the isomers of hexane. Here they are, nice and pretty. Okay, and again, you don't have to use the zigzag method. If you want to put all the carbons and H's in, you're perfectly welcome to do that. All right, now for homework, I'd like you to try and find all the isomers for heptane. I will tell you there are 9, and I even will go so far as to tell you I have them written out in your notes, but I want you to try and find them yourself first without peeking. So let's review what you have for homework, because remember, organic is practice, practice, practice. You have an alkene worksheet and an alkane worksheet from last week. They were posted last Friday with the answer keys. I just posted an alkyne worksheet. I want you to read your textbook and do the questions that I have listed within your notes here. Okay, so by this point, by Wednesday, you should have read the first 3 sections of chapter 22. And then, of course, I want you to do the isomers, okay? Practice, practice, practice. It's going to be beautiful weather out there today, so get this done now before you go. I'm going to try and have your 5th credit assignment ready for tomorrow, Tuesday. Alrighty. Have a good day. Bye.